Hello there, Miss Matthew. Merry Christmas. And today I'll be talking about perpendicular bisectors in proving. So before we get to the illustration and to the proving itself, let's define a perpendicular bisector. So a perpendicular bisector is a line segment that starts from the vertex of a triangle and ends at the opposite side's midpoint. And at that midpoint, a perpendicular angle is formed. So yeah, let's get to the illustration now. So here is a close look of our triangle illustration. Our given is that angles 1 and 2 are complementary and segment AD is congruent with segment DC. And we must prove that segment BD is a perpendicular bisector. So now let's start the proving. So based on our given, it says that angle 1 and angle 2 are complementary. Therefore, we can say that angle 1 and angle 2 are equal to 90. And the reason behind that is because the definition of complementary angles says that two angles whose sum of their measures is 90 and that they can be adjacent or non-adjacent. So in this case, the two angles are non-adjacent, but they're both equal to 90, so therefore they are complementary angles. Looking at the illustration, we can see that angles 1, 2, and 3 of the triangle are interior angles. So we must state in our proving that angles 1, 2, and 3 are interior angles of a triangle. And behind that, the reason is because of the definition of interior angles of a triangle, which states that all angles within a triangle are interior angles. Now, since all angles 1, 2, and 3 are interior angles, we can say that angles 1, 2, and 3 sum is 180 because the triangle angle sum theorem states that all interior angles within a triangle, the sum is 180 degrees. Now, since we have the equation of measure of angle 1 plus measure of angle 2 plus measure of angle 3 is equal to 180, we can substitute measure of angle 1 plus measure of angle 2 with 90, since I stated before that the measure of angle 1 plus measure of angle 2 is equal to 90. So I can say that 90 plus the measure of angle 3 is equal to 180. And I do that because of substitution, because I substituted measure of angle 1 plus measure of angle 2 with 90 based off the last equation. So again, with that equation, I transfer 90 to the other side and using the addition property of equality, so I can solve the equation. And now simplifying the equation, 180 minus 90 is equal to 90. Therefore, we can say that the measure of angle 3 is equal to 90. Now, since the measure of angle 3 is equal to 90, we can say that the angle 3 is a right angle because the definition of a right angle states that the measure of an angle is 90 degrees and it is a right angle. So now that we've solved for all the reasons and that it was given in the given that segment AD is congruent with segment DC, all we had to do was find that angle 3 or angle 4 is a right angle or is a 90 degree angle, so it'll prove that segment BD is indeed a perpendicular bisector. And now we have all those reasons thanks to our solution.